So we'll start with very basics. We'll start with the fact that what is dynamic programming, and probably we won't get into the details. What is dynamic programming? Probably what we will do is we'll solve a dynamic programming problem, and during that explanation around that problem, I'll explain you, and probably you will better understand what dynamic programming is all about. And then we'll go into the details that what exactly is the difference between greedy problems and dynamic programming problems. And then we'll go into the details of solving knapsack problems, knapsack and its variation. And similarly, at the end, we'll talk about the questions which are related to dynamic programming that are asked in competitive programming and interviews. How do we prepare? How do we go afterwards? How do we go from here to getting a dynamic programming mastery? So obviously we can't learn everything in a 1 or 1.5 hour session. So obviously we have to dig deep. And for that, probably I'll give you a roadmap that what all questions to do, how to categorize the questions of dynamic programming, and what all things you have to learn. And problems, as it was requested by many in the comment section, that these should be non-classical problems. So I have tried to keep non-classical problems, like I have kept one problem which is not that standard to describe you the difference between greedy and dynamic programming. Loot houses is also not such a standard problem, but we have to keep one classical problem, which is knapsack, because classical problems are those problems which explain you the concept very well. And then obviously we would dig deep into all the questions that are there we will basically categorize all the questions, right? So that is one thing. Okay, so let's wait for a while. Probably things would stabilize. We have 494 people who are waiting currently. So shall we start, or should we wait for a while? Right? Just let me know if we can start with the webinar, or should we wait for a while so that other people can join? Right. So I think we can start. I think we should start. So that is enough attendance, and basically we should start. So I'll start with the loot house problem, and I'll refer my notes as well, because and I'll refer your comment section as well, because DP is something which is very relevant. Okay. And the first problem, the loot house problem, probably we will try to understand the dynamic programming concept with the help of the problem only. So let me first explain you the loot house problem. So what is given in this question? We are given a array of integers. So let's suppose the array of integer which is given to me is, the example which I have is, I have 6, I have 7, I have 1, I have 3, I have 8, I have 2, I have 4. And I have been given with an array of integers. You can make intelligent guesses, and obviously you have gone through the recursion webinar. So obviously the first step to solve any dynamic programming problem would be to solve it recursively. So be on your toes, try to solve this problem recursively. So I'm again explaining the question. You are given an array of integers, and what you have to find is, you have to find maximum sum such that you are not taking any adjacent elements. So you don't have to take adjacent elements together. So no adjacent elements have to be taken. So no adjacent element has to be taken. You have to find the maximum sum which can be generated out of this array of n integers, such that no adjacent element is taken. So one way is that I can take 7. I can take 7. Then obviously this 1 cannot be taken, 6 cannot be taken. I can take 8, right? And I can probably take 4, right? So these are the people that I can take. So the sum that I'll get is 7 plus 8 plus 4. That would be equal to 19. So I have another option as well. What I can do is, I can take 6, I can take 1, I can take 8, and I can take 4. So that would be equivalent to that would be equal to probably 19, right? So we can take any of these values. I can take this one or that one. We can take any of these two combinations. The maximum sum that I can take without taking adjacent elements into consideration is 19. So the answer to this is 19. So this is the question that you have to solve. And now if I talk about how to solve this question, the first step is obviously recursion solution. So don't think about any dynamic programming or anything else. Just try to solve this problem using recursive method. So as we have already discussed, right? So I would basically reiterate everything in just a jiffy. So basically you can recharge what I have taught in the recursion webinar. First thing that we do is we create an expectation, right? So expectation is what I want from this function, what I want this function to achieve. And this is obviously the problem itself, right? So this is the problem itself, which is given to me. That is the expectation. So try to formalize your expectation, right? So if I basically write the recursive function for you, so let's suppose this is the recursive function given to you. Int function is the function that you have to write, and you are provided with the array. You are provided with the array. You have to basically find the maximum value in this array. And currently you are standing at the ith index, right? So this is the function which is given to you. So currently you are standing at the ith index, and the amount of array that you can see is from I to n minus 1. So let's suppose if the question that the running example that we had was 6, 7, 1, and it was 3, 8, 2, 4. And let's suppose you are currently standing at this index. So if you are currently standing at this index, that means you are standing at index 3. So what is the amount of array that you are seeing? The amount of array that you are seeing is this. So you have to find the maximum sum such that no adjacent elements are taken, and you have to find the maximum sum such that the array that you are seeing it starts from I and it goes all the way at the end till n minus 1. So this is the expectation from the question. This is the recursive function that I have to write, right? So the next step, obviously, as I had described in the function in the recursion webinar, we have to keep a faith. We have to solve this expectation. We have to achieve this expectation. So what we will do is we will create a faith. We will create a faith on the sub problem that the answer to the sub problem would come. And basically what we would do is the third step would be, with the help of the answer of the faith, we will try to solve the expectation. With the help of the answer of the sub problem, we would try to achieve the answer of the problem, right? So this is what we have to do. Now, the fourth step would be to create a high level code, right? I had previously described you in the recursion webinar that for me, high level code is a code in which there is no base case. So what I'll do is I'll first set an expectation, then I'll set a faith, then I'll try to achieve my expectation from the faith, and then I'll write high level code from it, right? So this is how things would happen. So before going ahead, there is a fifth step and there is a sixth step as well. So before going into fifth and sixth step, let's try to implement the first 4 steps into the function, right? This is a good webinar because it will revise you. It will make all your concepts of recursion also, it will revise everything that you have learned in the recursion webinar as well. So what I'll do is, this is the expectation. Expectation is already set. It is very important to focus on the words that I have used. You have to set the expectation right. So my expectation is that I'm standing at the ith index, and the array that I am able to see is starting from I and it is going to n minus 1, right? It's going from I to n minus 1. So I have to find the maximum sum that I can generate. I have to find the maximum sum that I can generate such that no adjacent elements are together out of the array that I am able to see, I to n minus 1, right? So this is the question that I have to solve. So my expectation is the question that I have to solve. And what is my faith? Faith is just the sub problem, a sub part that I would basically tell that answer to this sub problem would automatically come. So faith is a sub problem is a smaller part of the bigger question, that I would have faith the answer to this problem would automatically come. I don't have to think how the answer would come. I can basically have faith, and I have to create this faith, and I have to keep this faith that the answer to this sub problem would come. And with the help of this sub problem's answer, I'll try to achieve the answer of the actual bigger problem, right? And then I'll create the high level code. So somebody has told me that this is the expectation that you have. This is the expectation that you have, that your array is starting from the ith index. So my array is, let's suppose, starting from the ith index. Let's suppose this is my ith index, and somebody tells me find the maximum such that no adjacent elements are taken together. So I'll tell him two things, that bhai, I need two faiths. One is, once I take this into the answer, right? So you have two answers, right? I had one answer which was equal to 6 plus 1 plus 8 plus 4. This was one maximum sum, and the another maximum sum that I had was 7 plus 8 plus 4. These were two maximum answers that I had. Now this maximum answer had 6 into it, and this maximum answer didn't have 6 into it. So the answer can have the ith element or it cannot have. There are only two things. It can have the ith element or it cannot contain ith element. So I'll take two recursive calls. I'll say that make a recursive call, and the first recursive call is when I'm taking this into account. So I'll say that make a recursive call for this. So I'll say ki you look into itna array, you look into this much of array and find the maximum. Okay? So find the maximum out of it. If I find maximum out of this, I'm reiterating this, I would take two faiths. If I want to solve this question, I would take two faiths. First faith is when I take the ith element into account. The second faith is when I'm not taking ith element into account. So I'll make two faiths. So this is my first recursive call, and this is my when I'm not taking the ith element. So when I'm not taking the ith element, then I'll directly say that if I'm not taking ith element into account, then I'll make a recursive call to array comma I plus 1. Just look into the recursive call. It's very important to have a recursive solution to figure out what the dynamic programming solution would be. Because dynamic programming is simply an extension, or it's an optimization to the recursion only. So the first call that I'm making is that my ith element would not come into the solution. So if ith element is not coming into the solution, so the best solution would come when I make a recursive call for I plus 1. So if 6 is not coming into the solution, the maximum sum that I can get is from I plus 1 to n minus 1. And I'll say the answer for this would come. Answer would come into ANS, right? This is my answer 1. And the second recursive call that I would make is when I take 6 into account. So my second thing would be, my answer 2 would be func of when I've taken, just answer this question for me. When I've taken I into account, then obviously I cannot take I plus 1. So what I would do is I'll make a recursive call to func of I plus 2. This is when I'm taking 6 into account. And since I've taken 6 into account, so I'll add 6 over there. So what I've done is I've made a recursive call and I've said that find the maximum for this part. Find the maximum for this part. Find the maximum for I plus 2 till n minus 1. And whatever will be the maximum sum out of it, I'll add my value to it, which is array of I, So my second option would be equal to 6 array of I plus func of array comma I plus 2. So this is my faith. Now let's try to find that what would be the expectation if my answer 1 and answer 2 have already been solved. So we have to assume that the answer to this problem will come automatically. We have to assume that the answer to this recursive call would come automatically. We don't have to think anything. We have to keep these sub problems into place, right? So after the answer to this has come, so what we would do is our answer would be maximum of A1 comma A2. My answer would obviously equal to maximum of A1 comma A2. You have to understand, you have to first learn what will be the answer to this solution. right? You have to understand this recursive solution, right? So this is the recursive solution that I have found. But the problem with this solution is that this is obviously an infinite recursion. It's high level code. It has something which I have just imagined ki our answer to this will automatically come. And I found the answer to the original problem by just saying that the answer to this problem would automatically come. But obviously I have to dry run it. I have to figure out whether this question is correct or not. So what I would do is I would dry run and debug to find whether this assumption is correct or not. And second thing is I'll dry run and find the base case. So now dry run to find the base case. So what I'll do is I'll quickly write this code properly in a separate good writing, and then we'll dry run it. So the solution that I found is something like this. So solution that I found is something like this. First, you have to, Baba, create this high level code. There is no escaping from this high level code, right? So this is my A1. This is my first vector when I'm not including the ith element. And this vector would be equal to array comma I plus 1. So this is the no call. And then the second factor would be equal to A2 func array comma I plus 2. You would possibly have starting, you should have got some idea. So this is something that I missed. First array of I would come, then func plus array comma I plus 2 will come. And then I will return maximum of A1 comma A2. Now we would dry run it. But obviously the function that I used earlier was very big. The test case that I used earlier was of the length of 7 or 8 elements. So what I'll do is I'll quickly form the, I'll take a smaller test case and quickly dry run it so that I can figure out what would be the answer or what would be the base case, right? So what we would do is the the test case that I would use is 6, 5, 1, 3, and 8. So this is the test case that I would use, right? And I have to figure out the maximum sum that can be generated out of it, right? And the maximum sum, as you can see, it would be equal to 6 plus 1 plus 8, right? We have to keep in mind maximum sum has to be generated by not taking adjacent elements into account, right? So what I'll do is I'll take these elements into account, and this is my 0th index, this is my first index, this is my second, this is my third, and this is my 4th index. Let me quickly make it a little smaller so that we can have sufficient amount of space to dry run all this, right? I hope you have got sufficient space. So what I'll do, I'll start with the 0th index, and this is the array. So my array, let's give him a hypothetical address of 4K. In all the recursive call, what I've done is I have not changed the value of my address. Array is always ARR. So if my hypothetical address is equal to 4K, then it would remain same. And my array is created in the heap. So let me start with this thing. This is my first recursive call. This is my second call. And this is my third line. So first I'll execute the first line. When I execute the first line, it will simply make a call to 1, 4K. Just try to imagine what I'm doing over here is. So over here, what I'm saying is that try to find the maximum of this much amount of array, 5138, right? So over here, the first recursive call that I would make is I would make first recursive call to 2, 4K. So obviously what I'm doing, I'm shrinking my array. So let's go ahead over this. The first recursive call that it would make is it would make recursive call to 3, 4K, right? Over here, what amount of array I am seeing? I'm seeing the array from 3 to n-1. So 3 to 4. The array that I have in my hand is 3, 8. So this is the array that I'm seeing over here. So what I'll do is I'll quickly make a recursive call. The first call would make a recursive, and this would be equal to 4, 4K. And the array that I'm seeing over here is only equal to 8. So what I could say is that the maximum answer to this, I know. Right? So if there is only one element in the array, what is the maximum sum that you can generate? Yeah, if there is only one element, so the maximum sum that you can generate is equal to array of I. So there is one base case that I have got. I can say that if the ith index that you are standing over here, over there, if it is equal to array dot size minus 1, right? If it is Java, it will give you the size of the array. If it is not Java, basically you can take the size of the array with you in all the recursive calls. So size of the array is 5. So you can take it in all the recursive calls like this. So once the value of I reaches to a point where 4 is double equal to 5 minus 1, then what I could say is, then this is something which is very trivial and I don't want to break it down into further subsections. And I can directly say that my answer would be equal to return array of I, right? So this is something which I have understood. So the answer from over here would be 8. Then I'll make the second recursive call. And the second recursive call that I would make is, it would be equal to 5, 4k. Now this is something which is beyond the array indices, right? Fifth index is not there in the array. So there is another base case that I have to check, right? Which is basically, there is no element at this index. So if I becomes greater than or equal to array dot size, so whatever is the size of the array, if my I becomes equal to that, then obviously I have to return 0, right? You understand this? I would call it a negative base case because it is not contributing anything to the result. And I would call this a positive base case because it is contributing me an answer. So I'm just solving a recursive problem up till this point. So what I would do is, this would return 0. And basically what I did was, over here, my A1 would be equal to 8 and my A2 would be equal to the element at this index plus this factor. So A2 would be equal to 3 plus 0, which is equal to 3. And my answer would be equal to maximum of these two. So my answer would be equal to 8. And let me just confirm this thing. So the answer to 3, 4k is 8. So 3, 4k means that if the array which is given to you is this much of the size, then what is the maximum amount or what is the maximum number that you can generate? What is the maximum sum that you can generate such that no adjacent elements are taken? Obviously, the answer to it is 8 because you can either take 3 or you can take 8. And obviously, the answer which has come out is correct, right? Now, let's try to solve it further. So A1 over here is equal to 8. Right? Now, a second recursive call would be made. A second recursive call would be made. And the second recursive call would be made to 4, 4k. And obviously 4, 4k is my base case. It would return 8. This is factor 1 and this is factor 2. So a factor 2 would be equal to array of 2 plus 8, which is equal to 1 plus 8. So out of these two, which is bigger? Obviously 1 plus 8 is bigger. So what I would do is I would return maximum of these two, which would be 9. So the value that I'm getting is out of 2 to 4. Basically the answer to this is 9, which means in the array which starts at the second index and ends at the last index, which is 1, 3, 8, the maximum value that I can generate such that no adjacent elements are taken into account, the maximum value is 9. And as you can already see, this is 1, 8. This is what I can take, right? So try to go with the flow, try to go with the question, and you would have good understanding around each and every concept that I'll take into account. So now this has returned 9. So obviously this has gone, and now I'll return to this function. So A1 contains 9. Now it will make a second recursive call. So the second recursive call it would go to 3, 4k. Now 3, 4k is something that I have already solved. Yahan pe what it would do is it would make the recursive tree again. But I already know that the answer to 3, k would not change. 3, 4k is something which would not change, right? Matlab, answer to it is 8. And even if I again commute, if I can again compute everything, then also the same recursive calls would be made. And since same recursive calls would be made, so the answer would be exactly same. So what I can say from here is I am directly writing the answer without making all the recursive calls. So the factor that has come out of 3, 4k is 8. So my factor 2 would be equal to 5 plus 8, which is 13. So maximum of 9, 13 is equal to 13. So one factor for this would be 13. Now, obviously, this point over here, what it would do is it would make another recursive call, which would be equivalent to 2, 4k. And obviously 2, 4k, we know the answer for 2, 4k. It is 9. So the answer to the 2, 4k is 9. But this is computer. If it would not know, it would make the recursive calls again. It would make the same tree again. It would make the same tree which it had made over here again. And which is not needed. The answer would obviously be 9. And this is what we want to avoid. So we want to avoid creating these or creating a tree of repeated recursive calls. That is something which is very important. You don't have to create repeated recursive calls, right? So right now what I'm doing is I'm not making the same tree again. I'm directly returning 9 from here, and I would add that element at the 0th index, which is equal to 6. So this factor would be equal to 15, and this factor over here is 13. So out of these two, the maximum over here is 15. So my answer is 15. So the test case that I was trying to solve, 6, 5, 1, 3, 8, the maximum sum that I can generate by not keeping adjacent elements into account is equal to 15. And then the elements are, one is 6, other is 1, and last is 8. So these are the elements. And there are two things that we have done by creating this exercise of doing these recursive calls, and by doing this dry run exercise. We have done two things. First, we have figured out the base cases. Second thing, we have figured out that my hypothesis is correct. That faith expectation wala story is exactly correct. That is something that I wanted to figure out. So quickly let me know if you have understood or not, and we will move ahead. But first, let me know if you have understood this much or not. And I'm writing the question again for you. So over here, what I will do, I'll keep the size again over here. So I'm writing the full code for you, and I am adding those base cases as well. So if I is greater than or equal to size, I have to return 0, right? So that is one thing that I have to do. And if I is less than size minus 1, I'm quickly writing everything for you so that you can understand everything. And just let me know if you have understood this much of part or not. There are two base cases. This is one base case which I call as the positive base case, and this is negative base case for me. There are two factors. A1 is equal to func of ARR, comma I plus 1, comma size. Size and ARR are not changing. Now A2 is equal to func ARR, comma I plus 2, comma size. And whatever would be the result, I'll add array of I to it. And I'll return maximum of A1, comma A2. So I want to quickly stop over here. And what I want to do is, I want to ask you if you have any doubts till this part. Right? Right. So I have got too many comments. Rishabh saying they have understood exactly, and basically Rakshit is saying they have understood. Muhammad is saying, please explain base cases again. I've completely dry runned everything. And basically, I think if you do dry run again, you would understand that base cases are when I get to a point where I is equal to array.size minus 1. That's the point where my array contains only one element. And that is the point where the maximum sum that I can generate is equal to array of I only. The maximum sum that I can generate is equal to array of I only. So that's my positive base case. That's my one base case, Mohammed and Kushagra. And the other base case is if my I is greater than or equal to array of size, I'll return 0. Because if this is the test case, and if my I is equal to the last element, yani this much array, I'm seeing this much array. So that means this much array can only have one answer, which is 8. But if my I has reached to this point, then this means, then obviously that I'm not seeing any array, right? So if I got to an index where basically it is greater than or equal to size, then I should return 0 from there. I should get, I should come back to the tree from there, right? And Kuldeep, Sony, and all the people, Devinder Singh, all those who are asking whether it would be positive or whether it would be negative, it would work for the negative elements as well, right? It would work for the negative values as well, right? And for another person who's asking, what is I? I to begin with would be equal to 0. Yeah. Matlab over here, what I have done is from the main, I have taken 0, 0,4k, right? So Devendra Singh, I'm again repeating for you, all the array elements should not be positive. Negative elements can also work. Negative values can also work, right? And you can dry run this everything on a negative array as well. So it doesn't matter. You can keep in -5 over here. Then also your answer will come correct, right? So what I can do is, for simplicity, what you can assume that all the values can be kept positive till now. So let's do one thing. For simplicity, keep all the elements as positive, right? Okay. And the value of I to begin with the main, it would be equal to 0, right? So I think I have answered a lot of queries. And to last query, I just want to answer to the Sakshi's query, negative value. So Sakshi, let's assume that all the values are positive. Let's assume all the values are positive. So K is nothing, Sudeep. There is nothing, Sudeep. So now let's move ahead. So what we are doing is, what we should do over here is, there is something which you should understand, that what I was doing over here is, I was making this tree again. This whole tree was built again. The whole tree was being built again. So that is something that I don't want to do. I don't want to create the whole tree again. So there is something that I have to do for this part. So let's keep our focus on this tree only. So I want to figure out that this 3,4k, I don't want to create the whole tree again, and I want to check whether the answer for the 3,4k has already come or not. So if 3,4k has been answered one time, then I don't want to get the same answer again and create all the recursive calls again and again. It will only create function overheads, right? And the answer to this would obviously equal to 8. Answer won't change. So what I would do is, I would basically do the simple thing. So I would say that take the answer once, calculate answer once. So these are the simple words which you have to take into account. Calculate answer once, store it, and whenever you have to use that answer again, just use it, right? So just use it. So if you have to if you get a query which is equivalent to anything related to the answer which you have already calculated, then use it from the storage. So you have to store the answers, right? So that's one thing you have to do. Now there is a simple question that comes to my mind. How to identify whether we have calculated or not? So we will use a storage array. So one thing that I have to do is, I have to identify recursive calls. This is the keyword over here, identify recursive calls. So when I talk about identify recursive calls, then I have to see these things, that this is 0,4k, this is 1,4k, this is 2,4k. How many variables are there in the recursive calls? I want you to answer in the comment section. How many variables are you seeing over here? I think there is only one variable which is basically keep updating itself, which is varying. So it is equal to I, right? So it is equal to I. Over here, the I is only one thing which is varying. So something that I get from here is that the variable part. Now let us move down. The variable part is only 1 and it is equal to I. So since the variable part is only 1, so what I would do is, I would create a 1D array. So if the variable part are 2, then I would create a 2D array to store the values. And if there are 3 variables, I would basically, what I would do is, I would create a 3D array and so on and so forth, right? So over here, I is only the variable part. And so what I would do is, I would create a 1D array. Now, the second question comes is, what should be the size of the 1D array? So the size of the 1D array would be equal to the maximum value that it goes, right? So the variable part I, how much it is varying? It is going to 0, it is going to 1, it is going to 2. What is the maximum value that it goes? It goes to 5, 4k. So I have to create 1D array which have 0, 1, 2, 3, 4, and 5 as the indices. So if the size of the array is equal to, let's suppose 5, as in our case, this was our case, right? 6, 1, 3, and 8. This was our case. So the size of the array was 5. So what we have to do is we have to create a 2D array which is equal to size plus 1, so that this value can come as the index, right? So now what I would do is, this is something that I have created, right? And what I would do is I would take this array and I would take this storage and I would keep it everywhere. So there is something that I would do. Let me quickly, okay, I will write code for this and I would use C++ for it. But what I want to emphasize on is I've created this array which is equal to size plus 1. So what I would do is, in the starting, none of the values has been answered. So I will create a value equal, I would basically fill them with -1. So I will quickly explain you why I have filled with -1. So before doing that, what I should focus on is I have to write the code again, right? I have to write the code again. Or shall we use this code only? So let's use this code only. Let's not create the code again and again. So what I would focus on is I would write this value, this result array over here. So what I would do is, whatever array I have created to store the results, this is to store the results. I have to pass it to each recursive calls, right? So let's name it RES. Let's name it RES. So what I would do is I would pass in the recursive function. So let me write RES over here. So this is my RES. Let me increase the font. So this is RES. I hope you are able to see, right? And I would pass it over here as well. This is the RES and this is another RES, right? So to begin with, what I would do is, this is my result array, which is storing each and every result. This is an answer to 0, 4k. This is an answer to 1, 4k. This is an answer to 2, 4k. What I've done is, you have to focus on, I have mapped each recursive call with a storage location. I've mapped each recursive call with a storage location. And initially, none of the recursive calls have been answered. I don't know an answer to 0, 4k. I don't know an answer to 1, 4k. So initially, to identify, to show that none of the values has been answered, none of the calls have been answered, what I've done is I have entered -1 at all the places. So -1 indicates that that answer has not been calculated. -1 cannot be the answer, right? -1 cannot be the answer because all the elements are positive. So I have written -1, which indicates that the answer has not been calculated, right? So what I would do is, now I would come back over here. So what I would do is, I would make a small call over here and I would say, if RES of I is double equal to -1, then you have to make these 3 statements. If the answer is not calculated, then only you have to make these 3 calls. And a small line that I would write over here is that if RES of I is not equal to -1, if it is something which is equal to non-1, then return RES of I. That means that answer has already been calculated and you can return it. This would come somewhere over here. So I already had 2 base cases. I would add another base case, which would be equal to, if RES of I is not equal to -1, return RES of I, right? So this is a third base case which I have added, right? So let's move ahead. And another thing that I have done is, I have to do is, before returning the answer, I have to store it also. Because if the RES of I is not equal, is double equal to -1, then I would calculate the answers for A1, I would calculate the answers for A2, And before returning, I would store the answer. I would say res of I is equal to max of a1 comma a2. So this is something that I would add over here. This is something that I would add over here. And then I would return max of a1 comma a2. Right? So once this code is ready, what we can do is now we can try to again dry run, and now let's see how much effect this part keeps over here. So is my recursive call, is my recursive tree same now also? Is it same, or has the recursive overhead or the function calls have gone down some bit? So let's try to find it. Let's try to dry run for this code. This is the code that you have to do. First, what I have done is I have added res over here. I have added another base case, and before returning, I have stored in the res. So this is the three changes that I have done. So these are three changes that you have to keep in mind. I'm just repeating them. The first case is you have to create a storage array. The second is you have to basically check if the answer has already been calculated or not. If the answer is already calculated, return it. If it has not been calculated, make the recursive calls, and basically before returning, store it. So create a storage array, add a base case, and store it. So these are the three changes that you have to add in your solution. And basically with the help, by adding these three solutions, what you would do is by adding these three steps, your solution would become a DP solution. And this solution is called memoization. Let's quickly dry run for this part. Let's quickly dry run for this part. I think you are able to see the function over here, and let's quickly dry run. So the first recursive call would be made to 0, 4k. This would make a call to 1, 4k. This would obviously make a call to 2, 4k. This would obviously would make call to 3, 4k. This would obviously would make call to 4, 4k. Now this is my base case. This would return 8 over here. This would return 8 over here. So my factor 1 for this is 8. Now this would make another recursive call, which is equal to 5, 4k. I would get 0 from here. So what I would do is I would basically add 3 to it. 0 plus 3, one factor would be equal to 3. The other factor would be equal to 8. And the value for 3, 4k would be equal to 8. And before returning, what I would do is I would go to res of I and I would store the result. Res of I is equal to 3. So I'll go to 3. And what I would do is I would store 8 over here. This is the step that you have to see very carefully. So I've stored 8 over here. Now the factor 1 for 2, 4k would be equal to 8. It would make another recursive call. It would make recursive call equal to 4, 4k. Which is a base case. It would return 8. I would add 1 to it. This would be equal to 9. So maximum of these two values is 9. Before returning, I would store 9 over here. In res of 2, I would store 9. So that is one important thing that you have to understand. I would return 9 over here, and I would make another recursive call from 3, 4k. This is the interesting part that you have to focus on. Answer to 3 is already non-1. So what I would do is I would not make the whole tree above it. I would directly return 8 from here. I would see that the answer to this has already been stored, and I would return 8 from here. And I'll add in 8, what I would do is I'll add 5, and the answer for 1, 4k would be equal to 13, 9, and maximum of these two is 13. Before returning, what I would do is I would store 13 over here. I would store 13 over here. Now it would make another recursive call, which is equal to 2, 4k. This is another interesting part. I will not make the whole tree. I would directly get the result from the storage part, and I would return 9 from there. And then I will I will add the values which is stored at the 0th index, which is equal to 6. 6 plus 9 is equal to 15. And value of 0, 4k is equal to 15, because maximum of these two values is 15. So before returning, I would add 15 over here. What I have achieved out of it, I am not making these recursive calls now. So repeated recursive calls are not made. Repeated recursive calls are not made. So this is one interesting part that we have to focus on. right? And this is adding memory, adding storage array, adding storage array to basically to the normal recursive solution. So what we have done is we have added a storage locations, we have added an array to the normal recursive solution. Another thing that we have done is we have mapped recursive call to the storage locations. That is one thing which is very important, right? So before moving to the final part, I would basically just want to explain you that this is called memoization. This is called memoization, adding storage location to the recursion function. There are two steps in memoization. First, you have to create the storage array. Then you have to add a base case, add base case, that if the answer to that is already calculated, then I would return for that. And before returning, you have to add a storage step. So these are the three steps that you have to focus on, and these are very important. And before moving to the tabulation part, to moving to the third part, I would basically want to ask you whether you have understood this much part or not. So the three parts of DP solution, first is the recursive solution. You have to think about the recursion solution. Then the second part is equal to the memoization part, which we have just discussed. And the third is tabulation part. Just let me know if you have understood this much part or not. The thing that I'll do in the tabulation part, I will try to find the answer from the storage location only. So what I would do is I'll take the recursive, I'll try to make the whole answer without using the recursive tree, right? So basically what I've done is I've mapped everything. To storage location. I've mapped a recursive call to the storage location. So now that recursive approach is not needed. Yeah. So I can basically, what I can do is I can solve the answer from the storage location only. Okay. So one question that I would like to answer from Rishabh is that why we have taken the n+1 array. So why we have taken the n+1 array. So we understood that why we have taken the 1D array. So that was because there was one variable, Rishabh. Second thing, Rishabh, we have to understand how much values that variable was varying. It was varying from 0 to 5. What is 5 for us? It is equal to size. So now since we are mapping the recursive call to a storage location, we have to make sure that this 5 is also added. 5 will also be added when basically what we would do is we'll make that recursive storage function equal to storage function equal to size +1 or n+1. I want to add 5 also, right? Yeah. So any more questions? I think I have answered Rishabh. And please try to answer your questions among yourself, buddies. What you can do is, if somebody is not able to understand how function calling mechanism works, if somebody is not able to understand basic recursion, if he has not gone through all the webinar that I have given, what you can do is you can try to answer him. It would be, I would be very thankful if you can answer him or her in the comment section. That would be very helpful. So now I would like to move to the next part, which is memoization part. I think I have answered enough. So now let's move to the next part. And over here, the main objective is I'll try to solve the complete solution by storage location. I want to find the complete solution by storage locations. So I would not make recursive calls now. I would just make, and I will obviously solve the complete answer through the storage array only. So let me change the color of the pen. I hope now it's more visible to you. Okay, probably now it's more visible to you. So obviously the storage location, storage array would be equal to n+1. So what I would do is I would create an array of n+1. The storage array, I would try to solve the whole array. I would try to solve the whole function, whole problem using the storage location. So I'll first create the same array, which I had created for the storage array in the memoization. So that would be equal to n+1. So this is the array that I would store. Now the second thing that I have to focus on, what was my answer? So my answer in the recursion was equal to 0,4k. What is 0,4k over here? This is 0,4k. So my answer would be equal to result of 0. The answer to the whole problem would be equal to result of 0. The second that I have to focus on, how I was solving result of I. So how I was solving func of I, it was being solved by two values. I was taking max of func of I plus 1. So let me basically do something like this. And func of I plus 1. And the second value that I was taking was array of I plus func of I plus 2. Now you have to map it. So if func of I is equal to these values, so my res of I would be equal to max of res of I plus 1, array of I plus res of I plus 2. So this is the simple mapping that you have to do. Now another thing, the last thing that you have to do is, in the recursive part, what I was doing was I would starting from the 0,4k. I went all the way up to base case, and then from base case I again came back and I found the answer for 0,4k. From here, what we have to do is we have to start from the base case and we have to come back. So what are the base case? This is one base case which is equal to 0. And the another base case is this value which is equal to 8. So this is equal to area of I only, and this is equal to 0. These are two base cases whose answer I know. Now res of 3 is equal to 8, max of 3 plus 0. I'm mapping the recursive calls to this. So this would be equal to 8. Now dp of 2 would be equal to 8, this value plus the value of this. So this is 1 plus 8. So what I'm doing over here is the answer would be 9. So answer of res of 1 would be equal to 9, the value at 1 which is 5 plus 8 which would be equal to 13. The maximum of 9, 13 is 13. So answer of res of 1 is 13. Now answer of res of 0. This is equal to 13, 9 plus 6. And the maximum of these two values would be 15. And my answer would be equal to 15. So this is how you solve this question. So this is how you solve this question. So what I've done is I've started from the base case. First I filled these two values. From these two values, I filled this. From these two values, I have filled this. From these two values, I have filled this. From these two values, I have filled this. And this is my answer. So generally what you would see is you would see a lot of people trying to solve dynamic programming directly using tabulation. But what I would suggest you is that you should first try to solve recursively. Then what you should do is you should move to the memoization part. And then from the memoization part, you should look into the array. You should look into the storage array. And then you should look into the recursive calls. You should map these recursive calls to the storage location. Then you should start from the base case, and from there you should form your answer. So I hope you have understood this part. Just let me know if you've understood. Right, so I will quickly move to the comment section, and for the next 2 minutes, I'll see if somebody has any doubts. So there is something called Shikha. Shikha Malik is answering a lot of answers. Thank you, Shikha. And basically, okay, Shubham Chaudhary saying it doesn't have any questions. Okay, so Dipanshu Yadav is asking again. So, okay, so if array of I include negative values, what would be the value while initializing res of I? So you have to figure out something, right? So Dipanshu, what you can do is you can initialize it with minus infinity. And another thing that I can do is I can basically add null values to them. So there is another concept that you have to figure out. So this is another concept that you have to figure out. In Java, what they do is they create an object, they create a class. Now this is something which is very advanced. I'm taking you from the journal Dynamic Programming Discussions to the Object Programming discussions. So rather than storing a normal integer over there, so what they do is they store an object, and that object contains an integer. That object contains only one integer, right? So that contains only one integer. So I would basically, to begin with, I'll store null everywhere. So that null would differentiate if we would have negative values. So if we would have negative values, so that would basically, Dipanshu, we would store that object, and by default the values of that object will be null. So null means that the answer has not been calculated. If it is not null, then that means that answer has already been stored, and I can return that. As Sadia is saying, I could store integer.min value as well. I can put -infinity as well, right? Vanraj, whatever I'm explaining over here, this is language independent. This is language independent. Okay, so probably you have understood. Yeah, so Devinder, yes, we can move from 0 to n as well. We need to change the base cases accordingly. Yeah. Okay. Now Ashupriya is saying how the values are stored in the resultant array. So that you have to go back and you have to see. I have elaborately explained. The complexity is same, Ritesh. The question that you're asking is what is the use of tabulation if memoization is available? So there are some constraints, and basically Ritesh, sometimes the time complexity is very constrained, and what I can say is that there are some function overheads with memoization. So that function overheads had to be rectified, and that has to be removed. So if I basically completely try to solve it with storage locations, then I won't have those function overheads. Yeah, so Arul, I have written the quick code over here. And I would basically, what I will do is I'll share the notes. So over here, I'll not go into detail, but I would basically store the I will basically share the notes, and from there you can get to the code really properly. And Stack Overflow is another problem that happens, Devinder. I'll get to it in a moment. Now let's move to the next question. I want to explain you that what is the difference between greedy and what is the difference between your dynamic programming, right? So I'll first give you the question, and then I'll give you 2 minutes to think about that, and then we will basically try to solve it, right? So this is the question that I wanted to give it to you. So the question is, let me quickly go through my notes so that I can give you that question. So you are given an array. So font is really big. Okay. So you are given an array of n integers. And these n integer would denote your tower heights. Right? Just quickly listen to the question. And what I would suggest you is just listen to the question and then try to figure out. I'll give you 2 minutes. And then basically what we can do is we can give you 2 minutes. And with those 2 minutes, you can try to solve this question. So you're given an array of n integers, and each integer maintains a tower height. You are also given a value k. What you have to do is you have to change each tower height. You can increase the tower height by plus k, or you can decrease the tower height by minus k. So these are the two options that you have. So you have to you have to create the minimum difference. You have to minimize the difference between the longest tower and the smallest tower. So by changing each height by plus k and minus k, you have to minimize the difference between the longest tower and the smallest tower. You have to print the minimum difference. You have to minimize the difference between the longest and the smallest height. Let me quickly explain the question with the help of an example. So this is 1, 5, 15, and 10. So these are 4 towers that are given to me. This is height 1, and then this is height 5. Then this tower is height 15, and this tower over here is height 10. So this is 10, this is 15, this is 5, and this is 1. Right? So what I would say over here is that this part over here. So I basically the value of k is equal to 3. So I can either make +3 or -3. I have to change the value of each and every tower. I would have to change the value of each and every tower. That is something which is given to me. I cannot leave any tower. So what I would do is, by changing each tower's height, I have to minimize the difference between the longest and the smallest heights. So currently the difference between the longest and the basically between the longest and the smallest is equal to 15 minus 1, which is equal to 9. So I have to minimize it. So obviously, if the maximum height is this, and I have to minimize the difference, and this is my smallest height. So what I would do is the smallest one ko to I would do +3, and the biggest one ko I would do -3. So this would become 4 and this would become 12. And accordingly, I will make this 8 and I would make this 12. So I would change this accordingly. I would make +3 over here. I would not 12, sorry, this would be made 7. I would do -3 over here. I would do -3 over here, and I would do +3 over here. So according to it, now the difference would be equal to 12 minus 4, which would be equal to 8. So this is the minimum possible difference. Sorry. I basically I took it as 10. So this is 14. I'm sorry. Thank you for rectifying that part. And so this is something that you have to minimize, right? So the minimum height difference is equal to 8. So this is something that you have to print. I'll give you 2 more minutes to think about it. And we have Umang Ahuja, who's trying to answer the questions, and basically he's saying that take the average of the first and the last value and add, subtract if the element is above, add else if basically it's below. Yeah, Umang, that looks like the correct answer. Now you have to figure out that is there a DP solution to it also? So is there a DP solution to it also? You have to figure that out. I'll give you 2 minutes. I'll leave you with this part for the 2 minutes and figure out, and then basically we would continue with the solution. I would talk about the DP solution as well, and I'll talk about the greedy solution as well. And then basically we can figure out what is the difference between these two. So I'm basically closing my video for a minute, right? Okay, so I basically just let me know when I can start explaining the solution, and basically when I can start describing the solution to you. Just let me know when I can do that. So Ashu is saying that first take the average of all the numbers, will add or subtract 3 from each of the array element comparing to the average. So everybody over here has an objective answer. So if I talk about Umang or if I can talk about Ashu, everybody is having an objective answer that you have a clear distinction whether you want to add something or you don't want to add something. Right? So let me explain you the answer. So this was the question that was given to us. So obviously what we would do is we would first sort it, right? So first we would sort it. So why I'm sorting it, I'll just let you know. So if I want to minimize the difference between the maximum tower and the minimum tower, if I want to minimize that, so what I would do is, obviously I would apply a minus k to the maximum tower, and to the minimum tower, I would do a plus k. So this is something that I have to do. So what I would do is I would basically take this value and I would decrement it by 3, and this is 3, and I'll increment this value to 4. And obviously after doing this part, I would left with this much amount of array. So these are the values which are not changed. I'm very objective about the fact that this value would be incremented and this value would be decrementing. I think this part is very much clear to you, because I want to minimize the difference, and basically for that the first tower has to be increased and the second tower has to be decreased. The maximum tower has to be decreased. Now there is a pattern which is formed. So the maximum is 12 and the minimum is 4. So now the difference is equal to 8. Now there are 4 options. I'll go to each tower left. So I have 2 options. If I do plus 3 to it, I'll get an 8. If I do minus 3 to it, I'll get a 2. And the range that I have over here is, the range is 12 to 4. After applying this value, I have this range. The minimum value is 4 and the maximum value is 12. I obviously cannot shrink this, the difference. I cannot shrink this difference furthermore, right? So what we would do is, I cannot shrink this difference anymore. But obviously, if I basically take 2 over here, so my minimum value would change to 2. So this difference would obviously increase. So I have to basically figure out this spot, that if there are 2 options that I have, and if one option is increasing my difference and other is obviously smalling my difference, or basically it's not changing my difference. So what I would do is, I would take that counterpart which is not changing my difference. So if I take the 8 counterpart, so 8 would come between these 2 values. So my difference of maximum and minimum will not change. But if I take a 5 is 2, then minimum would be updated and difference would increase. I don't have to increase the difference. I have to make it as minimum as possible. So 8 would be taken for 5. Now for 10, what I do, I have 2 options. One is minus 3 and plus 3. Minus 3 would give me 7 and plus 3 would give me basically 13. 13 would increase the difference. I would not take it. I would take 7. So 7 lies between these 2 values. So I would say that 7 is something that I would take. Now you understand. And then I would basically at the end, I'll take the maximum and the minimum and I'll print the difference for that. Now this is the solution. I hope that you have understood. This is the greedy solution. Now let me talk about the dynamic programming solution as well. So what dynamic programming does is, it basically traverses each and every path. You've just seen in the past question, which was the loot house problem, which was the maximum sum such that no adjacent elements are taken. Over there, what I was doing was, I took elements and I was going for each and every possible case. I was taking the ith element in one case and I was not taking the ith element in another case. So if I talk about the dynamic programming solution over here, so what I would do is, I'll decrement this part by minus k, I'll make it as 12, I'll increment this by 4. This is something that I'll do. My maximum is equal to 12 and my minimum is equal to 4. And I would basically start with these values. So first I have to make choice for 1. In dynamic programming, I'll make both the choices. I'll make plus 3 and I would make minus 3. So if I do plus 3, then the element at the first index, which is equal to 5, if I do plus 3, then it would become equal to 8. And if I do minus 3, it would become equal to 2. Right? And obviously over here, I would make another 2 recursive calls. If I have converted this value to 2, and if I have converted this value to 8, so let's rub it from here. So these are 2 choices for the first index. Now I have to make 2 choices for the second index as well. So the second index is 10. So if the value is 8, then I would basically make 2 recursive calls for the 10. And if the value is basically 2 over here, then my minimum would be updated. My minimum would be equal to 12,2. And I would make 2 calls for 10. One is equal to plus 3, another is equal to minus 3. If I take it as 8, my maximum will be 12 and my minimum would be equal to 4. No changes in the maximum and the minimum value. Obviously, there would be 2 recursive calls. This is plus 3 and minus 3. And over here, basically, if I do plus 3, so that would be 13 and my maximum would be updated. It would become 13,4. And if I do minus 3, my maximum and minimum would not be updated. If I do over here, if I do plus 3, then it would become 13,2. And over here, it would become 13,2. If I do minus 3, then it would become 12,2. So this is the dynamic programming tree, right? So this is the dynamic programming tree. I'm trying to go through each and every element. Yeah. So I'm going through each and every element, and basically I'm going through each and every comment, and basically I'm trying to see over here. So you are saying it has become too messy. So is that so? Okay, so I just wanted to say that there is a DP solution to it. I don't want to get into the details. So there is a DP solution to it, and the DP solution, in DP solution, what I would do is I would traverse each and every path, and out of these 4 solutions, the best solution is this one, right? So this is the best solution. But in the greedy, now what I was doing in greedy, I am basically standing over here. I have 2 choices, plus 3 and minus 3. I would go to this path only. Just in one decision, I have discarded this whole tree. Okay, Sakshi, okay, Kirtan, okay, Siksha, okay, Ashish. I'll quickly repeat. So what I'm doing over here is, if this 1, 5, 10, and 15 is given to me, and if k is equal to 3, so the first thing that I would do is, first I'll sort it. After sorting it, what I will do is, I would take the first element and I'll increment it by plus k and I'll decrement it by minus k. This is equal to 4 now, and this is equal to 12 now. First, I'm describing you the solution. So now, basically, this is something which I would do in all cases. Plus k and minus k has to be done. Now, the maximum is equal to 12 and minimum is equal to 4. So now what I have to do is, in the second step, I'll traverse 5 and 10. I will traverse and I have to make decision for this much amount of array only. So what I would do is, I would ask for the 5, that should I do plus k or should I do minus k? If I do plus k, this would become 8. And if I do minus k, this would become 2. If I basically decrement, then this will become 2 and this will update the minimum. If the minimum is updated, then basically my current difference would be incremented to 2. I don't want to increase the difference. I want to keep it as minimum as possible. So I would convert this 5 to a part where basically it would basically decide that plus k should be done or minus k should be done. So I'll do it 8. There is a popular demand from Ashish is saying that would 9 be inserted or not? So let's insert 9. So let's keep 9 over here. So what I would do is I would basically, I have converted my 5 equal to 8. And after I keep 8, this difference would not be updated. Now let's talk about 9. Ashish, let's talk about 9. So this 9 over here would be basically either incremented or it would be decremented. So if I decrement 9 by 3, this would be equal to basically 6, or if incremented, this would be equal to 12. So this would, if either I do it plus k or I do it minus k. In any of the cases, basically the difference would not be updated. The difference between 4 and 12 would not be updated. So I can either I can convert this to 12, or I can convert it to 6. Any of these can be converted. Let's convert it into 12. 9 is converted into 12. So then also the difference is not updated. I want to keep the difference as minimum as possible. So I would convert these elements to a number that does not basically grow the difference. So what I would basically suggest you is for 10, there are two options. Either I want to make 13 or I want to make it 7. Obviously the choice is with 13, the difference would increase. I would make it 7. So this is the solution. And now Kirtan has got it, Shikha has got it, and basically a lot of people have got it. So now probably I can tell you that basically I'll keep updating maximum and minimum as I try to go for each index. And after basically traversing each and every element, I'll come out and I'll print the difference between maximum and minimum. Right? That would be my answer. Now, in this case, I want to explain the difference between greedy and DP. So this was the greedy solution. This was the greedy solution. Now let me come over here. So what we can say is, this is the tree that I would make. If I can quickly rub these things, I don't want to make this tree again and again. So I would quickly rub these things, and basically I would dry run this part again. So this is the decision that I'm taking for 5th value, and over here the decision that I'm taking is for the 10th value. So what I would do is I'm making 2 calls over here. One is +3 and the other call that I'm making is for -3. So if I do a +3, then it would be 8. And if I do it for -3, then it would become 2. In the greedy solution, I would discard this part. I would only make this call. So this whole tree is cut. At each point, I'm making one decision. Each point, I'm taking one decision. But in the DP, what I would do is I would make both recursive calls. So in DP, this whole tree would be made. And it will see what is the most optimal solution out of all the solutions that I have. I have 4 solutions. And out of this, the most optimal solution is 12,4. So this would be my answer. DP covers each and every path. DP covers every path. So this is something that you have to focus on. And if I talk about greedy, greedy takes a greedy choice, takes a greedy thing, right? So there is something that you have to focus on, that greedy has to take a decision. It takes a greedy decision. And that greedy decision, even if it takes a greedy decision, at the end, it comes out to be optimal. So you have to figure out those questions which are basically which can take greedy decision at each junction. So if the greedy decision gives me an optimal solution at the end, so what I will do is I will make greedy decisions that are basically more optimal. These are more optimal, but there are some cases where you have to cover each and every path. Now, if I move to the comment section, Arpit Jan is saying that in simple language, it should not change max and minimum value. Yeah, it should not change max and minimum value. And if both of them are changing max and minimum value, Arpit, then I would go to the point where max and minimum value, I'll go to that point where max and minimum value are being changed minimum, right? Okay. Ashish Prasad is asking if this was not optimization. Obviously, this is optimization. Then now the question which I have just solved, the maximum sum array question where adjacent elements cannot be taken, that cannot be solved without covering every path. So if I have to cover every path, for that optimization is only DP. And where I don't have to cover each path, for that the optimization is greedy. You have to figure that out, right? So here there are no optimal sub problems. Kirtan has very well described it. And I had one request from Kirtan that can you quickly write pseudocode for the DP solution with memoization? It would take a lot of time, and it would take time from our knapsack solution that I want to discuss. So that is something that I would leave to you, Kirtan, and I have high faith that you can basically, we have discussed it so much that you can easily describe it and basically you can easily figure out the solution from here, right? So I hope Arpit has written thanks, sir. So that means he has understood this part. Okay. Now let's move ahead. I would like to move to the knapsack part, and I would like to move to knapsack problem and its variation. So I would like to explain you about the knapsack problem and about its variations. Right. So before going to the next part, I have one question from Mahesh Chaudhary, and he's saying that, it was from Anshul Bansal. So it was that how can we do memoization if the constraints are 10 raised to the power 9? So this is good question. Let me quickly answer it. So there is a limitation to memoization. There is obviously memoization relies on the recursion part. It's just the recursion part plus memory. So what I would do is I would basically rely on the recursion, and recursion happens on the stack. Stack has a memory issue. Stack has a limited memory. It can only solve problems which have constraints up to 10 to the power 4. So obviously memoization cannot be applied everywhere. So what I would do is you have to figure out, you have to first apply recursion, then you have to find memoization, and then you have to go to tabulation. Obviously your answer only lies in the tabulation part. Your answer only lies in the tabulation part. But this memoization is necessary for you to drive the answer. You have to figure out the answer. So only memoization can give you those insights to go to the tabulation part. I hope that I have answered your question, Anshul. Stack memory is very limited, therefore you have to move to the tabulation part. Okay. The now let me talk about this part. Let me quickly rub this part. Okay, so I was talking about knapsack problem, and since we are running out of time, so now I would use a doc to explain this question to you. So just let me know if this doc part explanation works for you or not. So I have created notes for you, and would it work if I explain you the whole diagram and I explain you the whole problem with the help of the doc? Or would it basically benefit you more if I explain you as I've explained the first question? Right, just give me a quick answer. Do you want everything to go on the fly, or do you basically would you like to be learned on the doc? So would you want me to explain everything? I'm fine with that as well. Just quickly let me know in the comment section that are you fine with the doc, or basically would you want to go to that part? So Raghav and Kuldeep are saying doc, please. Doc is fine. Umang, Kirtan, Kuldeep, Raghav, everybody is saying doc is fine. Okay. So if the doc is fine, so let me thank you, Shikha. Thank you, Mahesh. Thank you everybody for the quick responses. So this is the question that I am trying to solve over here. The question is this is a 0-1 knapsack pattern. This doc I'll share with you. I'll share doc 1, which is related to the first question, and then this is the second question, which is related to 0-1 knapsack pattern. So I'll share both of the docs with you. Don't worry. Right. Okay. So the question is, you are given the weights array and you are given the profits array. So you have these 4 items. So one is apple, other is orange, and then is banana, and then is watermelon. So we have apple, we have orange, we have banana, we have watermelon. So what we want to do is a thief is coming to our house and he wants to make as much profit as possible. So he has a knapsack. He has a container where he can store things. And in this container, the capacity of this container is 5. So obviously the capacity of the container is 5. So he cannot store elements whose weight is greater than 5. The container will tear itself, and basically I cannot store anything which has a greater capacity than the given knapsack capacity. So weights is given to us. So that thief sees in my house there are 4 items. One is apple, orange, banana, and watermelon. And basically apple is of 2 kgs, then orange is of 3 kgs, then banana is of 1 kg, and then watermelon is of 4 kgs. If he steals apple, then the profit that he will get is 4 rupees. If he steals orange, the profit will be 5. If he steals banana, the profit would be 3. And if he steals watermelon, then the profit would be 7. So we want to maximize the profit. So if we want to maximize the profit, so what would be the best combination? What all elements he should basically steal? And he cannot steal something like this. Well, he cannot say that I'll take 1 kg of I'll take basically 1 kg of apple and 2 kgs of orange. He cannot take them in basically these forms. He can either take it full or he can leave it. So he can either take 2 kgs of apple, or he can take or he can totally leave the apple. So he cannot take a middle path. So either 0 or 1, either he can take it or he can leave it. So now if we talk about this case, so if we take all these things into consideration, and if he wants to get the maximum profit, then one case is that he can take apple plus orange. Total weight would be 5, profit would be 9. Then apple plus orange, this combination, total weight would be 3 and the profit would be 7. Then orange plus banana, total weight would be 4 and the profit would be 8. Banana plus watermelon, total weight would be 5 and the profit would be 10. So the maximum profit that I'm getting is, this is banana plus watermelon. This is the best combination that I'm getting. So what I will do is I would take this combination. Right. So I think you have understood the question. Just go through the problem statement once. So we are given 2 integer arrays. The first integer array represents weights. The second integer array represents profits of n items. We need to find subset of these items, and we need to find the subset which gives me the maximum profit. The maximum profit should be cultivated, should be aggregated such that the cumulative weight is not more than the knapsack capacity. Now each element can only be selected once. So either we can put that element on the knapsack or we can skip it. Right. So obviously, if I want to solve this question, so this is the way by which I can solve this question. So we talk about any generic point. Okay, so let us first try to solve this question by recursion. So obviously, as we have already discussed, this question can be has to be solved by DP. So the way to solve by DP is first I have to solve it by recursion, then I have to solve it by memoization, and the third step would be to convert it into tabulation. So we would basically what we would do is we will apply these 4 steps. So now the first step, let's talk about the first step. So in the first step, which is the recursion step. So let me first write the problem to you. So this is the problem which is given to you. So this is the function that I have to write. I have been given the weights array. So this is the weights array which is given to me. And this is the profits array. I'm not writing the syntax exactly. You will understand what is array and what is not the array. And over here, I would write the current index over there, over where I'm standing. And I would write the capacity. So given the current index where I'm standing, so if I have these, this is the test case which is given to me. So let me quickly write the test case. This is the weights array which is given to me. And this is the profits array which is given to me, 4, 5, 3, and 7. So let's suppose I'm standing at the first index and the capacity's value is equal to 5. Then this function wants me to answer that what is the maximum profit that you can generate by working on the array which starts at I and it goes till n-1. So what's the maximum profit that you can generate? So the maximum profit that I can generate obviously would lie on my faith. So similar to the faiths that I did for the first question, what I would do is for this question also, I would have similar faiths. I would have similar sub problems. For the ith index, it can come into my solution or it cannot come into my solution. I can take those apples or I can leave them. I can take that element or I can leave it. If I can basically describe the solution to for the ith index, so for each element I, either take that element, create a new set which includes item I. Now you can include it only if the total weight that you have does not exceed the capacity. Then only you can include it. So after including that element I, and just you have to figure this thing out, that you have to check whether the element, the weight of that element should not be greater than capacity. It should be less than or equal to capacity. So after including that element, recursively process for each element for the remaining items with the remaining capacity. Your capacity would also be changed. So let's suppose your capacity is equal to 5. If you include an element with the weight 3, so your capacity would be equal to 2. The capacity would change. So you would recursively try and figure out, recursively process for the remaining capacity and for the remaining items. That's when you include the item. If you do not include that item I, then you don't change your capacity and you directly recursively process for the remaining items. A profit would be returned by not taking item I, and a profit would be returned by including the item I. So let me quickly write over here. This is my answer 1, which is by including it. This is including it call, and A2 is the excluding it call. What I would do is, in including it call, I would add the profit of P of I, and my answer would be equal to maximum of E1, E2. Maximum of E1, E2. That is something that you have to focus on. My answer would be equal to, one answer is for the excluding part, another part is for the including part. So my answer would be equal to maximum of A1, E2. Right? So this is how this question would be solved. Now, if I move to a visual description of this problem, so let me quickly show you with the visual description. So this is how this question would evolve. So earlier, this is another test case which I have written over here, but you don't have to focus on the test case. You have to focus that there would be 2 recursive calls. One would be select A and other would be skip A. So select A, skip A, select A, skip A. Then this is select B, skip B. This is select C, skip C. This is select D, skip D. So this is how the whole tree would become. So what I want to focus on is that this is the recursive solution, and I would basically want to take you to the written code. So if I take you to the written code, this is the written code, right? So this is the first recursive call where I am including the element. So if I include the element, I can include the element only if the weight of current index, it is less than or equal to capacity. So I can include this only when weights of current index is less than or equal to capacity, right? So then I can include that element. and the remaining recursive call would be equal to capacity would be updated to capacity minus weights of current index, and current index would be updated to current index plus 1. And whatever answer would be returned by this recursive call, I would add profits of current index to it. And basically the result would be profit 1. And this is my first recursive call. The second recursive call would be made after excluding the element, which would be equal to knapsack of profits, weights, capacity will remain as it is, and the current index would be updated to current index plus 1. And the answer to this would be equal to profit 2, right? And my answer would be maximum of profit 1 and profit 2. And if I go to the base case part, this would be my base case. If my capacity becomes less than 0 or my current index becomes equal to greater than or equal to profits dot size, then I would return 0, right? So this is the recursive solution that you have to figure out, right? And this is the first part that you have probably understood, right? Now we would move to the memoization part. So just a quick question from everybody. How many variables do you see in it? How many variables do you see in it? I think there are 2 variables. I am changing my current index over here, and I'm also changing my capacity over here. So there are 2 variables. So since there are 2 variables, I would make a 2D array to store my results. So if I want to memoize everything, then I would have to create a 2D array. So have you understood this part? Just wait for 2 seconds over here. Just wait for 2 minutes over here. Shikha Malik is saying there will be 2 variables. Ashi is saying there will be 2 variables. Let's wait for 2 minutes over here. Have you understood this part? Gagan, you are exactly working. You are exactly correct. It's I and C. Anuj, there would be exactly 2 variables. And therefore, Rahul, exactly right. There would be 2 variables. And so that's why in my memoized array, in my storage array, what I would do is I would take 2 variables, right? So Ashish, I hope you have understood, right? I hope everybody is getting this. And to one question which was being asked in the comment section, it was that when would this webinar end? Basically, this webinar probably should have been ended at 9, but I don't want to basically wrap this up without explaining and giving intricacies or nuances of dynamic programming. Obviously, I cannot explain everything in just one class, in one webinar, but we are trying our best, right? So let's move ahead then, and probably there are 2 variables which you have already understood. Okay, so now let's talk about the overlapping subproblem. There have to be overlapping subproblems for a DP solution to exist. So if I take C, capacity is C, and the variable I, the current index is I. So I would make 2 recursive calls. This is my select wala call. This is my select call. Whenever I select something, whenever I select something, my capacity is changed, and my current index is incremented by 1. And whenever I don't select anything, when I skip something, so my capacity remains unchanged, and my current index becomes equal to 1, right? Similarly, C6 and I1, this would be equal to C4 I2 when I make a select call, when I make a yes call, and when I make a no call, it would be changed to C6 I2. So this is how this whole tree would, this is how the whole tree would look like. You can see that this part over here, these are the overlapping subproblems. Since I have taken a smaller array, since I have taken a small example, so there are many less overlapping subproblems. But if we talk about something which is bigger in size, if I take a test case which is very bigger in size, then basically what I can say is that this part, this C4I3 and the C4I3, there are only 1 overlapping subproblems which we are seeing over here. When we take a larger test case, you will see more overlapping subproblems coming into it. So the tree would be made again and again for C4I3, right? So I have to create a 2D array and I have to store the results. So now let's talk about the 2D array. So the first thing that I have to discuss about 2D array is its size. So obviously it's 2D. Now let's talk about size. So the first variable is I, is capacity, and the second variable is I. So I goes from 0 to size minus 1. So if the size is S, so I'll create my 2D array with the variable. I'll create my 2D array with the number of rows equal to the size. I can create a 2D array greater than it. There is no problem with that. But I cannot create a 2D array smaller than that. If I create a 2D array smaller than that, then it will give me wrong answers. If I talk about the capacity variable, now capacity, if you can see, capacity goes from 0 to C. The variability of the capacity goes from 0 to C. So obviously I have to create my columns equivalent to C plus 1. So my 2D array, the size of the 2D array would be equal to, the rows would be equal to the size of the weights array or the profits array, and the capacity would be equal to C plus 1, right? So that would include all these all these indices from 0 to C, right? So I have discussed about the 2D array, and I've discussed what would be the size of the 2D array and what would be the dimension of the 2D array. Now let's talk about what would be the 3 steps in the memoization. First step is I have to include an extra base case, right? The same base case that I have added in the last case. So over here, what I'll do is I'll create a 2D array and I will add -1 everywhere, because I want to identify that part, whether it has been answered or not. So if it is not equal to -1, return it. And if it is equal to -1, then make recursive calls. Second step is, oh, I've done a small mistake. The first step was creation of the 2D array. The first step was creation of the 2D array and passing the 2D array. The second step was include the base case. And the third step was before returning, you have to store it. Before returning, you have to store it. So these are the 3 steps. In the recursive solution, I'll add these 3 steps only, and I would be able to solve the problem, right? So I'm just making you to focus on the code with the memoization part. Just focus on the changes in the highlighted lines. The green, the gray highlighted lines. This is C++ code. I wanted to make this webinar language agnostic, language independent, but because of the paucity of time and because I wanted to explain you the abstract problem, I have to go to the part where I have to explain and I have to show you this doc which contains C++ code. So over here you have to see that I have created an array which where rows are equal to profits.size and the columns are equal to capacity plus 1. The other thing that you have to focus is I have filled everything with the value -1. Then I have passed this 2D array over here. Now base case would be exactly same. Base case would not change. This is an extra base case that would be added. If DP of current index and capacity, if it is not equal to -1, then I would return DP of current index and capacity, right? So this is one base case. So I have done 3 things. I have created the 2D array. The second thing is I have added a base case. And the third thing I would do is I would store before returning. This is the last thing that I would do. Store before returning. You don't have to get into details. You just have to apply these 3 steps into your recursive code and your memoization version is complete. This would have exactly same complexity as the tabulation part that we would be explaining ahead. But what you have to focus on is that these questions, that these would have exactly the same complexity. Memoization and tabulation don't have the same complexity. The only difference is memoization relies on the recursion part, and therefore recursion depends on stack, and stack has a limited memory. So it would not work if the test cases have greater constraints. If it is greater than 10 to the power 4, then it will not work. It would give you memory limit exceeded, right? So now basically before going to the tabulation part, I want to again move to the comment section and I want to see if you have any doubts. So one thing that I have is Upma is asking how to decide base case. Upma, for deciding the base case, as I have described this problem, I have described this part again and again. What you have to do is you have to figure out what the problem is asking. You have to figure out some sub problems whose answer will already come. And then from that sub problem's answer, you have to find the answer to that problem. Then you have to form a high level code. From the high level code, you have to dry run and debug from a small test case. And then you would basically find that, find the base case. When you dry run and debug, you would find the base cases. Dry run and debug. I have not dry run and debug this time. Ankita is asking why the size is C+1. Because the variable part, Ankita, the variable part is 0 to C. Variable part is 0 to C. So I want to include 0 as well as C index. I want to include all these indices. So these indices would only be included if I create columns with the size C+1. And similarly, if I talk about the question that Sakshi is asking, that why we are using 2D arrays. So as Shikha is saying that we have used 2D arrays because we have two variables in this case. Okay. Sakshi is asking why we have two varying paths. So Sakshi, because in the recursive solution, right, we have these two questions. We have current index is varying when we have capacity varying. So why these two are varying? Because we have built a recursive solution accordingly. Please go through the video again and you will be able to find answer to that. Now I want to move to the tabulation part. Now to move to the tabulation part, you have to use the same storage array that you have used for the memoization. Now I'm moving to the tabulation part. Now we are describing the tabulation part. I want to describe this question. I want to describe the solution for a small test case, and the small test case is equal to, what was the small test case? It was equal to 2314, and this was the weights array, and the profits array is equal to, let me quickly write it, 4, 5, and 3 and 7. And the capacity over here is equal to, the capacity over here that was given to us was 5. So the thing that you have to focus on is you have to find how that recursive function was calculating things. So if the capacity is C, I, so what it was doing is it was trying to find answers to two values. So it was making a yes call. The yes call was equal to C minus weights of I, and it was equal to C plus 1. And the second recursive call it was making was, it was making second recursive call to C, I plus 1. Right? So this gave me factor 2, this gave me factor 1. And my answer 2 was equal to factor 2. My answer 1 was equal to profits of I plus factor 1. And the answer to this value was equal to maximum of this value and this value. So this was the knapsack answer for us, right? Now, if I want to basically map it to the recursive solution, so it would be equal to dp of I, C. I'm mapping the index. I'm mapping the index to the row. I'm mapping the capacity to basically C over here, right? Capacity to the columns and index to the rows. So I would make two recursive calls over here. So the first recursive call or the first answer would be equal to P of I plus dp of I plus 1, and this would be equal to C minus W of I. Right? And the second answer would be dp of I plus 1 C. So if I want to find answers for this, answer of these values should already be been calculated. This would give me answer 1 and this would give me answer 2. So the maximum of these two values would be my answer. You can easily map these values. You can easily map these values. You can easily map these dp of ij values into a 2D array, right? Let me small it further again. Now probably you are able to see the whole 2D array. So this is 0, this is 1, this is 2, this is 3. I'll quickly form the 2D array. This is my indices, this is my rows, and my capacity should be equal to 1, 2, 3, 4, and 5. How do we start answering our question? How do we start answering our tabulation? We start answering our tabulation from base cases. So our base case is, so if I quickly explain you, if the capacity is less than or equal to 0, then we have to return 0. And if our I is greater than or equal to price dot size, then also we have to return 0, right? So if I can quickly explain you what should be the base cases. So when my I is equal to price profits dot size, the size of the profit is equal to 4. But there is no I equivalent to 4. So let me quickly form another value over here. This is the 4th index. And whenever the index is equal to the size of the array, then the value stored corresponding to it should be equal to 0. Right? So this is 0, 0, 0, 0, 0. So the value in the last bottom would be equal to 0. So I have created another row because my base case was not fitting. So now what I've done is rows are equal to the size plus 1 and the column are equal to C plus 1. I made a minor change just to fit my base cases. And the other base case was when capacity is 0. So this is my capacity variable. So this all would be equal to 0. First, I have to fill my base cases. So before going to the tabulation part, first I have to fill my base cases. Now I would try to solve my answer. So when you try to answer I comma C, I plus 1 row should already been filled. So if you want to fill 0th row, 1 should be filled. If you want to fill the first row, this should be filled. If you want to fill this part, this should already be filled. If you want to fill this part, this should already be filled. So from this part, you would answer this row. And from this row, you would answer this row. From this row, you would answer this row. And from this row, you would answer this row. I would only fill this row. I would only fill this row. And then probably I would rely on you to fill these 3 rows. Right? So let's try to solve this part. Let's try to fill this part. Let me quickly erase this part and let's quickly try to have some space. So this is the 2D array. This is the 2D array which is given to us. And what we will try to do is, first we will try to solve dp of 3, 1. If the capacity of 1 and if the dp of 3. So obviously, first thing that we have to understand is I'll make 2 calls. One is yes call and other is no call. So the capacity over here is 1 and the value of the weight is 4. The weight for the 3rd index is 4. So basically what we need to focus on is if the capacity is only 1 kg and the element that I want to steal is 4 kilos, I cannot add it over here. Do you understand this part? So obviously I cannot make this call. I can only make the skip call. And when I make the skip call, my skip call would be equal to dp of I plus 1 comma c, yani dp of 4, 1. Yani this part would be equal to this part. So this would be equal to 0, right? So this is completely filled. Now let's try to fill dp of 3, 2. Now my capacity is again equal. Now capacity is 2 kgs. When capacity is 2 kgs and the element at the 3rd index has a weight of 4, then obviously I cannot keep that element also. So the select call cannot be made. Only this call is made, which is equal to dp of 4 and 2. So over here, the answer would be exactly equal to this, which would be equal to 0. Similarly, if I try to solve this part also, this part would be equal to dp of 3, 3. So if I try to solve dp of 3, 3, then also my answer would be equal to same. Now my answer would be, I cannot make this call. Select call cannot be made because the capacity is 3 and the weight of the 3rd item is 4. Select call cannot be made. The only call that can be made is 4,3. Skip call can be made. So this would be 0. Now let's talk about another call. Now the next part. This part is when my index is 3, my capacity becomes equal to 4. Now this is interesting. Now over here the select call can be made. Skip call can obviously be made. Skip call would be equal to dp of 4,4. This would give me 0. And this would be equal to, the select call would be equal to p of 3 plus dp of the capacity that we have, which is 4 minus the weight that we have, which is equal to 4. And okay, I'm a little bit, I have basically just focus on this part. Just focus on this part. I'll again repeat. When we select, so we would take profit of 3 and we would make call to dp of 4. We would make call to dp of I plus 1, and capacity would be equal to C minus weights of I, which is equal to 4 minus 4, which is equal to 0. So my answer would be equal to profit of 3. Profit of 3 is equal to 7 plus dp of 4, 0. dp of 4, 0 is 0. So my value would be 7 plus 0 if I select it. And if I don't select it, then my answer would be equal to 4. So this would be 7, 0. So my answer would be equal to 7. So maximum of these two would be 7. And similarly, if I try to calculate dp of 3, 5, now the answer to that also would be equal to p of 3 plus dp. If you can quickly answer this, dp of 4, 1, right? I hope you have understood that. And if I can skip that, then it would be equal to dp of 4, 5. This is obviously equal to 0. This is 7. So 7 plus 0, this would be 7, and this is 0. So out of 7 and 0, what is maximum? 7 is maximum. So I would store 7 over here. So what I need you to focus is that for solving this row, I have used the next row. So what I need you to focus on is that if now I would basically try and solve this row, and I would use this row for that, then I'll try and solve this row and I'll use this row for that. And then at the end, I will try and solve the last row, right? So my answer would be stored in dp of 0, 5, which is equal to the fact that the array that I'm able to see is starting from 0 to n minus 1, and the capacity that I have is equal to 5. So this is the answer where the answer would be stored. So answer to this solution would be stored over here. So this is the answer. This is my answer. This is where the answer would be stored. And I hope I can basically move from, I can basically rely on you that you can start from the last. First, you will fill the base cases, then you will move to the second last row, then you'll move to this row, then you this row. And basically, I think you can do this part. And basically, I'll give you the notes as well. You can move to the tabulation part. You can see how tabulation is being done. And I think this much part I can rely on you. And let me move quickly move to the comment section. So thank you, Adar. Basically, if anybody has any doubts with the knapsack part, you have to focus on this part. You have to focus on this part. You have to focus that you have to first go to the recursive solution, then you have to go to memoization solution, and then you have to go to the tabulation part. Right. Okay. Sakshi, thank you. Ashish, thank you. Adhar, thank you. Thank you so much, Adhar. Okay. Now let's move to more insights. Now I would like to move to more insights. So this was one question, but as you can see, that the name of this doc is equal to dynamic programming 01 knapsack pattern. So why I have named it pattern? So I've named it pattern because I studied dynamic programming with the help of patterns. So all the problems which have similar recursion pattern, which has similar computations, which have everything similar to the to the 0-1 knapsack, I would put them into the 0-1 knapsack pattern. There are only 6-7 patterns when it comes to interview questions. Right, so when it comes to the interview problem, there are only 6-7 patterns. I'll describe the patterns to you, and there are some more questions that you can see over here. So what you can see over here is there are some more problems that I have added over here. So there are some set of positive numbers. So there are more problems which I have given you, right? So there are a set of positive numbers where we can partition into two subsets so that some of the elements in both the subsets are equal. Each element has to be added in either of the one sets. So we have to find true or false. We have to return answer in true or false, whether we can partition a set of elements into two subsets or not, right? So this is a question which is exactly based on 0-1 knapsack. So I would basically tell you to go for other problems as well, and I've created this doc for you, and in this doc we have a lot of problems, and all those problems they are completely related to 0-1 knapsack. And this is one doc which I've shared over here. It is related to the first question that we have done. So the first question that we had done was it has 1D array, it has one variable in it. So what I want to focus on in the Fibonacci pattern, I want to focus on problems which have only one variable. So this is one part that I want you to focus. The second thing and the last thing that I want to discuss over here is that how do we learn dynamic programming from here? So as I've just explained you that patterns of DP, there are some patterns of DP. So I would learn DP with the help of patterns. The first pattern that I see is 0-1 knapsack pattern. For me, if I teach in the classroom, if we teach in our classroom course or in the online course, so in our courses, what we do is we teach dynamic programming with the help of the pattern. So this is one pattern. This is 0-1 knapsack pattern. These 5 questions that I've written over here, these are standard questions, right? And all these patterns, all these questions are similar to 0-1 knapsack. Then there is unbounded knapsack, and all these questions, coin change, rod cutting, minimum coin change, maximum ribbon key, these are standard questions, Devinder. So if you would just search their name, then you would be able to find the problems on internet. So if you are able to learn from the internet, then I would basically share these names with you. We will share all the resources with you in the description in the first comment. And basically these are all the things that I would share with you, and anybody can learn if they are good enough, if they don't want the TA support, if they don't want the teacher support, and if they don't want the placement support, if they can't do everything with themselves, then probably they should learn from the internet, and they can learn from the internet. There are a lot of resources available, but the thing is, if you want help, then these courses are for you. The third pattern is related to Fibonacci numbers, and similarly the fourth pattern which I was talking about is related to palindromic subsequence, and it is mostly related to strings. Then there is this pattern which has the most questions for me, and it is longest common substring question. This is one pattern. And if I talk about the next part, so over here, the matrix chain multiplication pattern is the last pattern for me. And there will be 3 questions which would come in it. There will be matrix chain multiplication in it. There would be minimum palindromic cut in it. And there would be egg dropping in it. And if you learn all these questions, this would cover all the patterns. This would cover all the patterns. This would cover all the DP problems. Obviously, you have to go through more and more new problems. But if you talk about learning DP, then this should be the questions. This should be your target. First, learn these problems. By hook or crook, learn these problems. And basically, if you have to learn by rote learning, if you have to rote learn these problems, do that as well. Because everything is a twisted or tweaked version of these patterns. There are 2 kinds of people who train. So either I basically rely all my learnings on patterns, or I rely on all my learnings on originality. So less than 1% people in this world rely their learning, and basically they learn through originality. Most of the people learn from patterns. So learn from patterns. There is nothing wrong with learning from patterns. Rot these patterns, learn the DP relations between them, learn everything corresponding to them. And you would find that all the DP problems, all the new DP problems that you will encounter in the interview questions, or that you would encounter in the lead code contest, or for the code chef, or for the code forces contest, they would be a twisted or tweaked version of these problems only. So that's why they have been called as patterns. Every other question can be brought back and can be put into these categories. They can be put into these buckets. There are also those questions. There are questions of 3D DP. There are questions of 4D DP as well. But for the interview perspective, nobody asked you from the bracket, from these brackets. So nobody asks you away from these brackets. Everybody asks you from 2D array. From at most they go to 2D array. So if you are eyeing interviews, then I would basically tell you to focus on lead code. Try to do as many contests as possible. Try to solve these problems. Learn these problems from the internet. If you are eyeing big companies, big product-based companies like Google, DirectEye, or CodeNation, or Facebook, these are the companies which take competitive programming into considerations. And rest all the companies, starting from Amazon, Microsoft, and all these companies, they are big product-based companies, no doubt, but they don't take competitive programming into account. They basically even take your lead code into account. They more focus on your interview prep part. So that's the difference between our interview prep course and our competitive programming course. So if you want to go more into depth of algorithms, then you should go for competitive programming. And then basically you have to learn more into dynamic programming as well. But for the interviews perspective, these questions are completely perfect. I obviously would basically will go. I'll share all these resources with you, and basically I would basically share all these things as a comment, and we will also add in the description section. Don't worry about these things. Everything would be basically shared with you. Don't worry. Okay, and if you are a beginner, I would tell you that go with the lead code contest first. And when you are basically very comfortable with the lead code contest, then you should go to the code forces contest. But if you are only eyeing interviews, then just stick to lead code. Just stick to lead code. And if you want to go to the competitive programming, if you want to do good in competitive programming as well, then you should take one more step, and you should go to the competitive programming part as well, and you should go to the code forces. I would suggest code forces. I personally like code forces more than code chef, because the quality of question is the code chef has good quality of questions, and it has more difficult questions. Those kind of questions are actually not needed for somebody who is graduating. So that is something which you can skip for now. And if you are targeting ACM ICPC, or if you want to basically go for something higher into algorithms, then basically you should go to either code chef, or you should go to Coder. So any more question, guys? I want to wind up now. This has been 2 hours, and it was great interacting with you. Great set of questions. And now probably I just want to answer your questions. So if you have any questions, just put it in the comment section. I can see that Mahua has one request that he is requesting that please share these questions. I would obviously share these questions. I would share notes corresponding to the Fibonacci pattern and with the 01 knapsack pattern as well. Apart from that, Umang is saying, okay, thank you. So, okay. I just wanted you to basically focus on the overview part. This was the idea that we started off with, right? So just focus that these were the questions and these things are covered or not, right? Just focus on these parts. So a lot of comments are great. Thanks. Your webinar was awesome. And do regular in lockdown. Okay. Okay. Ashi is saying, is there any Coding Ninjas course? Obviously, there is Coding Ninjas course. We have a lot of courses, and there are 3 courses which cover dynamic programming, foundation, interview prep, and competitive programming. Okay. Anuj, sure, Anuj, I'll share the link. Thanks from Kuldeep. Thank you very much. Codebreaker, to answer your query, I would say LeetCode is the best resource available over here. It has very good curated content for the interviews. Ashi is saying, is there any Coding Ninjas course? I've already answered that. Can we get a recording of this webinar? Obviously, should be this is recorded, and it would be basically recorded and would be available for you. People choice, I would say start with LeetCode, and if you want to learn more, then I would say go to Code Forces. Rahul Garg, could you tell some things that how do we master DP? So for mastering DP, Rahul, I've just said that first rote learn these questions. I've already discussed there are 2 ways to learn. One way is that you can either learn from patterns or you can rely on your originality thinking. So I would basically say that rely on patterns first. Rahul, I have just answered your question. I remember Rahul from Punjab Engineering College. I think Rahul, you're the same Rahul, if I remember you. And Shikha, thank you. Prem, thank you. Shivam is saying, is solving more than 200 questions on LeetCode enough for cracking the interviews? You have to understand each question also, right? So you don't have to just go into questions and keep doing questions. You have to understand questions also. You have to understand those questions also, right? So like what I have done is I have created insights from each question. Whenever we are learning, so we are taking insights out of it. And whenever we are taking insights out of everything, that's how we learn and that's how we teach. So why would anybody learn from us if we can basically learn everything from book also? So if I cannot add anything to its learning, then why would anybody learn from me? So these are all the learnings that we have accumulated. And if you want to do it yourself, I would tell you to approach the problems, learn everything, and basically learn what, why, and how of the problem. Even if you see the answer to the problem, there is no problem with seeing the answer to the problem. What you should do is you should, if you have learned the answer, learn the what of the answer, learn why of the answer, and learn how of the answer. See the what, why, and how. Why is the most important part. When you understand why of the solution, then basically you can, what you can do is you can apply those things. Then you can apply those things to new questions as well. Right now, I would like to wrap up. It has been already 10:13. So if you have any more doubts, people, you can connect with me. And if you want to connect with me, I'll just let you know my email ID. So my email ID is navdeep@codingninjas.com. I would love to interact with you all, and I would answer all your queries. Just drop me a mail, and it's easier to answer your queries if you basically send them to email. So just shoot your queries to this email ID, navdeep@codingninjas.com. And quickly, if I can answer Prasu's answers, that will you get these certificates? We don't have certificates for the webinars, for the online webinars, because we basically have webinar where we have certificates for the coding events that we have. So that was all from my side, and you were a great audience. So thank you, thank you, thank you, thank you, thank you, thank you, everybody. Thank you, everybody. Now I'm ending the stream. Thank you for the patience.